Hello and Assalamualaikum everyone. We have here an example on Romberg integration. So this example is actually has been solved using a trapezoidal rule with three different size of segments. So as you can see in the table, we solve it once using one segment with the step size or the segment size is equal to 0.8. And then we solve it again using two segments, which means the segment size is half from the previous one or from the previous approximation. And then we solve it again using trapezoidal rule, this time using four segments, which was half of the size of the segments from the second approximation. So having this data, so we have three approximations using three different segments. From there we have three approximations of the integral and three different values of true error. So using this data, we will improve the estimation using Romberg integration. So let us start. I just put that table over there so it is easy for us to refer to it. Right. So let's say we start with the Romberg integration, which is applied to one segment and two segments approximation, which is that one, the one in the um, red square. So we have the first segment integral 0.1728 and the two segments integral 1.0688. Okay. Since the H2, which is the two segments approximation, is equal to H1 over 2, which means it is half of the first approximation segment size. And those two integrals, these two integrals have errors of estimates OH square, then the improved approximation can be expressed as this one. So it's a special type of Romberg integration where we apply a combination of two integrals which are having OH square as the error of estimates, and the segment size is half from the other one. So we can use that special equation. So we substitute those values. Okay, we have the values of I2 and I1. So we substitute it into the equations and we get the integral, or the improved integral is 1.367467. So take note that we don't do any trapezoidal rule over here again. We just use the information from the outcome of the previously solved using trapezoidal rule, and we simply combine it using this Romberg integration equation. So we get an improved estimation. So since we say it is an improved approximation, let's check the true error. So the true error is 0.27 and the percentage true error is 16.6%. So you can see that the one segment integral we use in the Romberg integration, initially it is 89.5% percentage true error, and then the other integral that we use is the two segments, which has 34.9% of true error. And then we combine it using Romberg integration, we got a new estimation with a very low error compared to the other two integral that we use for the Romberg integration, which is 16.6%. On the other hand, we can apply the Romberg integration as well to the two segments and the four segments. So we combine the two segments approximation and the four segment approximations, which is in the red square. So previously we applied to the 1 and 2 segments. Now we apply to the 2 and 4 segments. So we can anticipate that we will get an improved one, but let's check it out. So the two segments integral, we put it as I2. The integral is 1.0688 as given. And the four segments, we write it as I4. Okay, 4, or the subscript referring to the number of segments. which I4 is equal to 1.4848. So since the size of the segment is half from the other one, we can apply the special Romberg integration equation, which is this one. And take note that as we are applying the combination with having error of estimates OH square, then we use this equation. If we combine using OH to the power of 4, for example, we will have other special equation, which we will see in other example. So we substitute those values into the formula or equation, and we have I equal to 1.623467. So let's check whether it is really improve the solution. So the true error is 0.017067, and the percentage true error is 1%. So let's see that the original integrals were 34.9 and 9.5. Then after we improve it using Romberg integration, we have a 1% error of the new improved approximation. So we can say that Romberg integration can be used effectively, and it's quite efficient. So that's all for the first example of Romberg integration. We will see the other example on the other video. Thank you very much.